A lot of people have no idea, but this small red pebble showing up on your screen right now is a garnet, a stone that is pretty common across the United States. It is strongly linked to the presence of diamonds in nature, and depending on the region where it shows up, it can also be linked to the presence of gold. Now think about this question for a moment. What would you do if you found a small red pebble like this one in your own backyard or out on a family farm? Could there really be diamonds hidden right there under the ground you walk on every day without paying much attention, just waiting for someone to look closer? Well, this red pebble on its own does not mean very much, and finding one garnet alone does not guarantee any kind of fortune sitting under your property. But if you find the other stones I am about to show you in this video appearing together with this garnet, then you can consider yourself a very lucky person, because when these stones all show up together in the same place, your chances of standing on ground with real diamond potential go up by a serious amount. Today you will learn about 6 diamond indicator stones found in American soil with colors and shapes you can spot with the naked eye and no fancy gear at all. I will teach you what to look at, how to tell a stone that matters from a regular pebble, and what each color is telling you about the soil under your feet. And I need to warn you about something important before we start, because the 6th stone on this list is also the easiest one to find out of all of them. It has such a striking color and shows up in so many places across the United States that you have probably already seen one without realizing what it was. So stay with me until the end, because this last stone might be very close to your home, and after this video you will not be able to ignore it anymore. Before we get there, you need to understand one simple thing about how all of this actually works in nature, because that changes the way you see the ground. Diamonds form way down inside the earth, much deeper than any human has ever drilled, at depths of around 90 to 120 miles below the surface of our planet. Down there, the pressure is so intense and the heat so extreme that pure carbon slowly arranges itself into the crystal structure that we now call diamond. But forming a diamond down there is one thing, and bringing it up to where you and I can actually find it is a completely different story to understand. That trip from the mantle to the surface only happens through a very rare and very violent volcanic eruption that creates rocks called kimberlite and lamprite. These eruptions shoot up through the crust at incredible speeds, dragging chunks of the deep mantle along for the ride, including diamonds and other deep minerals. When that material reaches the surface, it cools down and hardens into rock, and over millions of years, that rock slowly breaks apart under rain, wind, and time. As the kimberlite breaks down over time, all the little crystals that were trapped inside get released into the soil and the gravel and the creeks around the area. And here is the part that changes everything, because diamonds are extremely rare, but the other minerals that came up with them are much more common in those rocks. Geologists figured out long ago that finding these companion minerals is far easier than finding the diamond itself, and the math actually favors you in this game. For every diamond inside a kimberlite, there can be thousands or even millions of these other crystals scattered around in the same soil layer near the surface. According to research from the Geological Survey and from major exploration companies, these crystals are the official trail that leads back to the source rock. They are called kimberlitic indicator minerals, and the most important ones include garnet, chromite, ilmenite, chrome diopside, and olivine, according to many field studies. The logic here is simple and elegant, because if you find one of these crystals, the rock that carried it had to pass through the diamond formation zone deep below. That does not guarantee a diamond will be sitting next to it, but it tells you that you are walking on ground that came from the right neighborhood far underground. And the best part is that each of these minerals has a personality of its own, with a color and a shape and a weight that make them stand out once you know what to do. Another thing worth knowing is that these crystals are tough enough to survive being moved around by rivers, by glaciers, and even by ants digging in the soil. That means you can find them far away from the kimberlite, sometimes miles downstream, sometimes carried by ice across entire states a long time ago. So when you walk along a creek or look at a roadside cut, you are basically reading a story written by water, rot, and time across thousands of years of history. The smartest gem hunters know this story by heart, and they pick their search spots based on how the land was shaped by ice, by water, and by ancient volcanic activity. Even your own backyard, if it sits on the right kind of old soil, might already have a few of these crystals waiting in the dirt for someone with the right eye to spot them. The first step is always learning what to look for, and that is exactly what the rest of this video is about, going stone by stone with the right details for each one. So let's start with the very first one on our list, a stone with a color so distinctive that once you see it for real, you will never look at green pebbles the same way. The first stone we need to talk about is called chrome diopside, and the name might sound a bit complicated, but the appearance of this stone is anything but. This is a bright, vivid green crystal, with a color so intense that some people describe it as looking exactly like a fresh leaf catching the morning sunlight. It gets that strong green color from chromium, which is the same chemical element that gives emeralds their classic deep green tone in the gem world today. In the field, chrome diopside usually shows up as small, glassy grains, often translucent enough that you can see light passing through the edges when you hold it up. The size varies a lot, but most pieces found in soil or gravel are about the size of a grain of rice or a small pea, sometimes a little bigger if you are lucky enough. The luster is what we call vitreous, which is just a fancy way of saying it shines like clean glass when the light hits it from a good angle in the open air. According to geology references, chrome diopside has a hardness around 5 to 6 on the Mohs scale, which is softer than quartz but harder than the tip of your fingernail. That hardness range matters because it tells you the crystal can survive in the soil for a long time without falling apart completely from years of weathering above ground. When you find one of these bright green grains in Cold Creek gravel or in iron-rich red soil, your internal alarm should go off because this is a really serious clue. Geologists use chrome diopside grains as one of the main trails to follow back to a buried kimberlite pipe, especially when the rock itself is hidden under vegetation. In the United States, regions in Colorado, Wyoming, and parts of Montana have produced reports of chrome diopside grains found in soil and stream samples over the years. To recognize it, the trick is to wet the pebble and look at it in good natural light because the wet surface really brings out that vivid emerald green color we want. If the green is dull or brownish or olive tones, you may be looking at a different mineral. But a clean, glassy, lively green is a strong signal to keep investigating that area. A simple field test is to compare the color to a fresh green leaf next to the pebble, because chrome diopside really does match that living, vibrant tone of plant life. You can also check the fracture by carefully looking at a broken edge with a small magnifier, since the inside often shows the same clean green that the surface does. And while you are searching, remember that these grains are usually small, so a simple pan and a steel sieve and patience will do far more for you than any expensive equipment. Another thing many beginners miss is that chrome diopside often shows up after a fresh rain, when the dust is washed off and the green color jumps out of the wet gravel. So a good time to go searching is right after a rainy day, when creeks are running clean and the surface stones have been washed by water and laid bare for your eyes. Always carry a small plastic bottle of clean water with you, because wetting a suspect pebble in the field is the fastest way to see the real color hiding underneath the dust. Now we move from a stone that catches your attention with color to a stone that almost hides from you, because the next one looks dark, heavy, and very easy to ignore. The second stone on our list is called picroilmenite, which is basically a magnesium-rich version of ilmenite, and it is one of the most reliable diamond clues out there. In the field, picroilmenite looks like small, rounded black grains with a metallic shine, sometimes described as a submetallic luster, similar to dark steel under soft light. It is heavier than most common pebbles around it, and that extra weight when you hold it in your hand is one of the first signs that you might have something special. The grains are usually smooth, rounded by the long journey from deep in the earth and by years of being pushed around by water and gravity in the surface soil. A streak test is one of the simple ways to check it, because picroilmenite leaves a dark brown to almost black mark when you scrape it on unglazed ceramic at home. You can use the back of a ceramic tile or the bottom of a coffee mug for that streak test, as long as the surface is rough and not glazed shiny like a normal plate. The hardness is around 5 to 6, similar to chrome diopside, so this mineral survives weathering long enough to end up scattered across the soil far from the original source. What sets picroilmenite apart from regular ilmenite is the magnesium content, and that little chemical difference is exactly what links this stone to diamond formation. Studies on kimberlite exploration confirm that magnesium-rich ilmenite is one of the classic indicator minerals tracked by professional diamond hunters all around the world. When you sift creek gravel and you start pulling out small, heavy, rounded black grains with a metallic shine, you stop and pay attention because the message is clear. Combine those black grains of bright green chrome diopside in the same gravel sample, and you have two strong signals pointing to the same hidden source nearby. Another useful tip is to keep a small bag of these heavy black grains and sort them at home in good light, since some details only show up when you have time and patience. Some prospectors even use a small kitchen scale to weigh suspect grains, because picroilmenite feels noticeably heavier than common pebbles of the same exact size. If you put a regular gravel pebble in one hand and a picroilmenite grain in the other, the picroilmenite grain will always feel denser, almost like a tiny piece of metal in disguise. That weight difference is your best friend, because over time, you start to feel which grains are worth keeping just by lifting them between your thumb and your finger. Now let's talk about a close relative of picroilmenite, which is regular ilmenite, also part of the indicator mineral toolkit used by exploration teams in the field. Ilmenite is an iron titanium oxide, and it shows up as small black grains, sometimes flat and tabular, and sometimes more rounded after being tumbled by water over time. The color is iron black, and the luster is metallic to submetallic, and the streak is dark brown, which helps you separate it from other dark minerals nearby in the gravel. According to mineral references, ilmenite has a hardness of about 5 to 6, and it is denser than common rock fragments, with a specific gravity close to 5 in most samples. That density is huge for you in the field, because dense minerals tend to settle in the same low-energy spots in a creek where heavy gold and diamond also end up. When you pan creek gravel and the black grains stick around in the bottom of the pan after you wash off the lighter material, that is a great sign we're following up on. A magnet test is also useful here, because regular ilmenite has weak magnetic properties, so a strong magnet might pick up the grains with a gentle pull, but not snap them. In glaciated parts of the northern United States, like the Great Lakes region, ilmenite grains can travel for many miles dragged along by ancient ice sheets long ago. That means a black grain in a Wisconsin creek might actually be telling a story that started hundreds of miles north in Canada, where a kimberlite once erupted long ago. For people who live in these glaciated states, the practical lesson is simple. You should always check the heavy black grains in your local creeks with full attention. The same goes for parts of Michigan, Minnesota, and even northern Indiana, where ancient ice did the heavy lifting of moving diamond-related materials south long ago. The big lesson with both picroilmenite and ilmenite is the same simple rule. Never throw out the heavy black grains until you understand what you are actually holding. A small magnet on a string is one of the cheapest and most useful tools you can carry because it helps you separate the magnetic grains from the slightly magnetic ones. True magnetite jumps to the magnet and sticks hard, while ilmenite usually just leans toward it or follows the magnet slowly as you drag it across a small pile of grains. That subtle reaction is exactly what tells you that you might be looking at ilmenite instead of common magnetite, which is everywhere in many parts of the country. Now we get to a mineral that looks almost too plain at first glance, but for diamond hunters, this is one of the most important little black grains in the whole game. Chromite is an iron chromium oxide and part of the spinel mineral group, and it shows up in the field as small dark octahedral grains with a submetallic shine. The color is dark brown to black, and the streak is dark brown, with a hardness about 5.5 on the Mohs scale, which makes it tough enough to survive in the soil for ages. What makes chromite so special is that it forms in the same deep, high-pressure environment where diamonds grow, and it often travels with them to the surface together. In fact, chromite is so closely tied to diamonds that small chromite crystals are sometimes found locked inside the diamonds themselves, as confirmed inclusions in studies. In the field, the grains tend to be small and usually under 1/4 of an inch, and they are heavy for their size, with a density much higher than common surface gravel. A magnet test gives a weak to moderate pull depending on the exact composition, but chromite is usually less magnetic than magnetite, which is a very common look-alike. If you find a small, hard, dark grain that survives a quartz scratch test and gives a brown streak on unglazed porcelain, chromite becomes a very real possibility for you. The presence of chromite alongside green chrome diopside and black picroilmenite is exactly the combination that exploration geologists dream of finding in a single sample. In states like Kansas, where Riley County actually contains real kimberlite intrusions that have been studied for decades, chromite has been documented in surface samples. According to scientific reports, the same kimberlite indicator package shows up across the Colorado-Wyoming state line district, where dozens of small pipes are known today. That part of the country has been studied by professional geologists for many years, and several real diamonds have been found in the soils and streams of that whole region. If you happen to live or travel through that part of the United States, paying attention to the heavy grains and local creeks is genuinely one of the smartest things you can do. Even a small backyard creek in a state with the right geology can carry indicator minerals that traveled miles from the original source, just waiting for someone to notice them. One detail that helps in the field is the shape, because true chromite often shows tiny 8-sided faces called octahedrons when the grain has not been too worn down. When you spot a heavy black grain with that geometric, almost crystal-like shape, instead of just a rounded blob, you're very likely looking at real chromite material. A small magnifying lens with about 10 times magnification helps a lot here, because the 8-sided faces of chromite are easier to see at the right angle. You can buy your basic jeweler's loupe online for just a few dollars, and it quickly becomes one of the most useful tools in any beginner gem hunter's pocket out in the field. If you live anywhere near old kimberlite areas in Kansas or Wyoming, taking a closer look at the heavy dark grains in local creeks is one of the smartest things you can do. The next stone on our list might surprise you a little because you probably already know it as a gemstone in jewelry stores under a much friendlier name, peridot. Peridot is the gem variety of olivine, specifically the magnesium-rich version that geologists call forsterite, and it is one of the most abundant minerals in the deep mantle. In the field, olivine shows up as small, glassy olive green to yellow-green grains, with a color that sits somewhere between fresh grass and the ripe lime in the kitchen. The luster is clean and vitreous, almost like green bottle glass, and the grains are usually rounded after being tumbled by water and weathering over very long periods. According to standard mineral references, olivine has a hardness of about 6.5 to 7 on the Mohs scale, so it scratches glass with a firm push and survives well in creek beds. Where olivine gets interesting for diamond hunters is that it is the dominant mineral in mantle peridotite, the exact type of rock that hosts diamonds at extreme depth. When kimberlite erupts, it tears off chunks of that peridotite and carries them up, and the olivine grains end up scattered in the soil after the host rock finally breaks down. But there is a small twist you need to know, because olivine also forms in basalt, which is a common volcanic rock that has nothing to do with diamonds at all in most cases. So finding olivine alone is not enough to confirm a kimberlite source nearby, but olivine plus the other indicator minerals together is a much stronger story to follow. In Arizona and New Mexico and parts of Hawaii, olivine is famously found in basalts as beautiful peridot crystals you can pick up right on the ground near lava flows. The Peridot Mesa area in Arizona on the San Carlos Apache Reservation is one of the most famous spots in the country for these bright green olivine crystals on the surface. The grains there are well known among collectors and jewelers, and gem-quality stones from that region end up in rings, necklaces, and earrings sold all over the country. The lesson here is simple. Treat olivine as a supporting clue in the bigger picture, and always check for chrome diopside and chromite and ilmenite in the same area. One easy way to tell olivine apart from a piece of green glass is the small, blocky shape, since olivine grains usually look like tiny, irregular chunks instead of smooth bits. Real olivine also has a slightly oily look in some lights, almost like the surface of an olive fruit, which is actually where the name of the mineral comes from in the first place. If you find clean, glassy olivine grains in a creek that drains a known kimberlite area, you should absolutely keep them even if you do not find diamonds nearby just yet. And finally, we get to the sixth stone on our list, the easiest one to recognize and probably the most famous indicator mineral in the entire diamond exploration world. This stone is called Pyrope garnet, and the name actually comes from the Greek words for fire and eye because of its deep glowing blood red color in the right light. Pyrope is a magnesium aluminum silicate, part of the garnet family, and it stands out from other garnets because it almost always shows that distinctive fiery red tone. Under sunlight, a good pyrope grain looks like a tiny drop of frozen wine, with a clean, transparent body and a vitreous shine that makes it almost impossible to miss. According to mineral references, pyrope has a hardness around 7 to 7.5 on the Mohs scale, which makes it tough enough to survive long distances inside creek gravel beds. The grains are usually small and often only a few millimeters across, rounded and dense and heavy enough to settle in the bottom of a pan during simple stream sampling. What makes pyrope so important for diamond exploration is the chrome-rich variety, called G10 pyrope, which is directly linked to the diamond stability zone in the mantle. Geological survey reports confirm that chrome pyrope, together with chromite and chrome diopside, forms the classic trio of solid diamond clues. In the field, the way to spot pyrope is to look for that deep, warm red to slightly violet color, especially in sandy soils and creek banks and along open roadside cuts. Many people in states like Arizona, Utah, and New Mexico already collect what they call anthill garnets, which are pyrope grains brought up by ants and termites from below. These anthills are famous in some areas because the insects dig deep enough to bring up tiny red garnets from layers of soil that humans rarely see directly themselves. The Four Corners region, where Arizona and Utah and Colorado and New Mexico meet, is one of the best-known areas in the country for finding these anthill pyrope garnets. In Arkansas, the Crater of Diamonds State Park sits on top of a real lamperite source, and visitors there sometimes find pyrope grains along with other small mineral clues. That park is one of the only places in the world where regular visitors can keep any diamond they happen to find, and pyrope grains are part of the surface gravel there. So if you ever come across a small red glassy grain in your yard or in a creek or on a trail, look at it carefully and weigh it on your palm and hold it up against the light. If the red has that warm, deep, fiery quality, and the grain is heavy for its tiny size, you might be holding a pyrope garnet that traveled from miles down in the earth. That little red drop in your hand might be far more than just a pretty pebble, because it could be the natural signature of rocks that came from the diamond zone deep below. A simple way to confirm a suspect pyrope is to shine a flashlight through the grain at night, since real pyrope usually lets the light pass with that warm, glowing red tone. If the grain looks dead inside and dark and opaque, even with strong light behind it, there's a good chance you're dealing with a different mineral instead of pyrope garnet.